if you want to reduce a triangle pattern with sides of 16, 16, and 20. So if you're looking at this triangle, we have 16, 16, and 20. Okay, and it says if the longest side of the new pattern is going to be 15 centimeters, how long should the other two sides be? Well, again, if you want, you can redraw it here. And you could also have just redrawn the line inside the figure itself, right? So the easiest way to reduce that wouldn't be to cut off portions from all three sides. It would simply be to cut off a portion so that this longest side is 15. And so ideally this is what you do, but if you want to look at the triangle separately, you can. Okay. So here's the triangle. The new piece is kind of embedded on top of this original. And so when you look at what's being created here, these triangles will be similar. They'll share this same vertex angle, and they'll have these base angles that are the same as well. Okay, so you do have these similar triangles. And so what we can now do is set up the ratio of their pieces. Well, we want to find what the length of the other two sides are. So let's call that length x. When you set up your ratio of sides, your proportion, again, I would suggest you start with your unknown. So x is 2. So x is the equal-sided length of the smaller triangle. It corresponds to the equal-sided length of the larger triangle, which is given as 16. And that's equal to the ratio of the known long side versus the new, or the original long side versus the new long side. Okay, which one goes on top, the 15 or the 20? Okay, because x is in the smaller triangle, we want to put the smaller sides, longest side here, the smaller triangle. So we have 15 over its corresponding side, 20. And now you simply solve your equation. Just multiply by 16. Again, it's often helpful to leave your multiplication as factors. Don't try to simplify until the end. And now you can simplify. X is equal to 5 goes into 15 3 times, 5 goes into 20 4 times, 4 goes into 16 4 times, 3 times 4 gives you 12. So you're able to solve that pretty quickly just with some simple calculations. All right, the next problem, question 5. Again, a pretty typical kind of word problem that you'll see in this chapter. Okay, but it says a 9-foot ladder leans against a building 7 feet above the ground. So let's say here's your building, here's the ground, and you have a ladder leaning against this. Okay, the ladder is 9 feet long, and it says it's leaning against a building 7 feet off the ground, or above the ground. So that's this leg up the building, up the side of the building. Okay, and what it asks is, what height would a 15-foot ladder touch the building if both ladders form the same angle with the ground? So again, we can take this as another example, in this case a 15-foot ladder, and we want to find what is its height. How high up is it? Okay, and so you have these, again, two similar triangles. They both have this right angle formed with the building. They both have a pair of corresponding angles, parallel lines, that are equal. So you're looking at two similar triangles. And so once again, if we take our unknown, which is h, over the side, the leg that corresponds to h is this vertical leg of 7. And that has to have the same ratio of any other corresponding pieces between these triangles. So h is the larger triangle, so we're going to start with the longer ladder length of 15 over the shorter one, 9. And it's just a matter of solving. So multiply both sides by 7. Again, you can simplify your fraction. 3 goes into 9 3 times. 3 goes into 15 5 times. 5 times 7 gives you 35 over 3. And if you're putting it in decimal form, which this problem asks, or this whole set of problems asks you to write decimals, you can convert that into decimals and answer your question.